Instrumental variables address an endogenous treatment where omitted confounding, reverse causality, or measurement error makes the treatment correlated with the regression disturbance. An instrument shifts treatment but does not directly affect the outcome. It isolates variation in treatment that is plausibly unrelated to the unobserved determinants of the outcome. The statistical machinery is straightforward. The hard part is defending why the instrument changes the outcome only through treatment and is itself exogenous. A valid instrument must satisfy three conditions. Relevance means it predicts treatment. Exclusion means it affects the outcome only through treatment. Exogeneity means it is unrelated to the unobserved determinants of the outcome. Relevance can be examined in the first stage regression. Exclusion and exogeneity are design assumptions that require substantive arguments and falsification checks. They cannot be certified by a large first-stage statistic. A strong but invalid instrument produces a precise answer to the wrong question. The letter increased the quitting rate from 20 to 43%, a difference of 23 percentage points. Children of mothers who received the letter were about 98 grams heavier at birth. Scaling that birth weight gain by the increase in quitting gives roughly 426 grams. Expressed as the effect of smoking rather than quitting, the sign is negative. Smoking lowers birth weight by about 426 grams for compliers. Three equations organize instrumental variables. The structural equation contains the causal treatment effect, but has endogenous treatment. The first stage measures how the instrument changes treatment. The reduced form measures how the instrument changes the outcome. With one valid instrument, the causal estimate is the reduced form effect divided by the first stage effect. That ratio is meaningful because exogeneity removes confounding of the instrument and exclusion channels its effect through treatment. Two-stage least squares generalizes the ratio to several instruments and controls. First, regress treatment on all instruments and exogenous controls and obtain fitted treatment. Second, regress the outcome on fitted treatment and the same controls. The fitted slope is the instrumental variable's estimate. Do not calculate ordinary second-stage standard errors by hand. They ignore that fitted treatment was estimated. Use dedicated software which provides the correct covariance matrix and first-stage diagnostics. A weak instrument changes treatment only slightly. In finite samples, the two-stage estimate is then biased toward ordinary least squares, and its standard errors are unreliable. The first-stage statistic is a diagnostic. A value above 10 is only a common screening rule, and with many instruments, much stronger evidence may be needed. Always report the first stage, but do not confuse strength with validity. An instrument can be strong, excluded by the model, and still violate the causal design. With heterogeneous effects, instrumental variables identify the local average treatment effect for compliers, people whose treatment follows the instrument. Always takers receive treatment regardless of assignment. Never takers never receive it, and defiers move in the opposite direction. Monotonicity rules out defiers. Under the remaining assumptions, two-stage least squares averages effects among compliers, not the full population. The resulting policy interpretation must therefore name the instrument and the behavior it induces.